Hey guys, we are going to try going over assignment 6 one more time. I'm going to give it one more shot. I think I figured out what was going on with Delta Math, why it was hating on me and not letting us submit our answers. So I'm going to go over it with you again and hopefully bypass that particular aspect of it and hopefully be able to get through all of assignment 6 with you. I hope that you worked on the ratios workbook 1 and ratios workbook 2. I saw some of those things turned in and I graded them, but I do want to go over the rest of assignment 6 with you. So we are going to present the screen now. I'm going to go here to Delta Math. Let's get rid of all of these things like this. Okay, let's go to Delta Math. Need some glasses here. All right, constant of proportionality from context. We already went over that some. Remember we said the constant of proportionality usually means you're finding your one. And they wanted to know the constant between earnings and time in hours. So they want to know how much per hour Sarah is making. All right, so, and we're going to use a different calculator too, because it's just a little bit easier. Okay, so we want to know if she makes $190.30 in 11 hours. How much does she make in one? So we're going to divide it by 11. So she makes $17.30 per hour. We're going to go ahead and submit that. Just say yes. And remember that I told you before, if you're doing it correctly, all of these, if you were to say $397.90 divided by 23, you would still come out with $17.30. All right, so we kind of already went over that on the last video, so we're going to go back. Compare rate of change and proportional relationships. We're going to take a look at this. All right, two friends, Juan and Joseph, took summer jobs. The graph below represents Juan's earnings in dollars and cents, Y for working X hours. All right, so these are the hours, and this is how much he made. All right, and this is for Juan. Joseph has a chart set up. How much less per hour does Juan earn than Joseph? All right, well, first thing we're going to do is we're going to figure out what Juan makes per hour. And we've got it right here. If he works 10 hours, he makes $273. So we can find out how much that is per hour by going 273 divided by 10. So he makes $27.30 per hour. So let's just move this over here out of the way. Let's write it here so that we see it, $27.30. Now that's not our final answer. We're just writing our number down so that we can refer back to it. Now we need to know how much Joseph makes per hour. Well, in 11 hours, he makes $304.70. So we have 304.70, right? $304.70 divided by 11 hours. So he makes $27.70 per hour. All right, and we want to know how much more he makes. So we're going to take away what Juan makes, and we'll know how much more he makes per hour. Well, we've got $27.70 minus 27.3 because it's $27.30. He makes 40 cents per hour more. All right, how much less does Juan earn? Well, he earns 40 cents per hour less. So Joseph makes 40 cents per hour more. So 40 cents essentially is our number that we're looking for. All right, let's make sure that, oh, looky there, Delta Math likes me again. Okay, so these problems like this, you're going to want to make sure that you, for example, in this one, Super Grocery A, they give you a chart. Super Grocery B, they give you a graph. I'm sorry, Super Grocery B gives you a chart. And we want to know how much would you save per pound if you buy your salmon at Super Grocery B rather than at Super Grocery A. Well, let's see how much it costs at Super Grocery A. Well, an easy way to do this is to take this, let's see, you can take either one of these. You can either say $111.40 divided by 10, or you can say $55.70 divided by 5. It doesn't really matter which one we use. We're still going to get the same rate. So let's use the 55.70. 55.70 divided by 5. So at Super Grocery A, salmon is $11.14 per pound. Let's just put our number down here so we don't forget it. $11.14 per pound. All right, Super Grocery B, you can get 1.5 pounds for $11.13. All right, let's see. Or here's 5 pounds right here for $37.10. So it doesn't really matter which one we use. So we're going to use $37.10, and we're going to divide that by 5. And that is $7.42. How much would you save per pound if you buy your salmon at Grocery B rather than Grocery A? Well, you're going to spend $11.14 at A, and you're going to spend $7.42 at B. So an easy way to do this on this calculator, I'm going to make this a negative number right here by clicking this plus minus. Or you can just redo it. You can say 11.14 minus 7.42, but I'm making it negative, and I'm just going to add the 11.14 on the calculator, and we get a savings of $3.72 per pound, right? 372, 372. Let's submit our answer and go. It's going to be ugly to me again. So Delta Math is starting to be ugly. It's okay. 372 is definitely the right way to do this. We figured this out per pound. We figured this out per pound. And they want to know how much you save per pound. So we found 1 pound here, and then we subtracted 1 pound here, and we saved 372 per pound. There it is right there. So what I'm going to do, I'm going to go back, and we're going to go on to the next section. Tables of equivalent ratios right here. All right, this says for a given recipe, 12 cups of flour are mixed with 24 cups of sugar. So how many cups of sugar should be used if 21 cups of flour are used? Assuming a constant ratio, fill out the table until you find the value. Well, 12 and 24, you could kind of see that to get to 12, to get from 12 to 24, you would multiply that by 2. Or to get rid of the 12, you could divide by 12 and find out how much 1 is. But we want to go to 21. So right here, we're going to say that we're going to divide by 12. I'm going to divide by 12 here and go. All right, so we've 1 cup of flour to 2 cups of sugar. All right, now what we can do is we can take this 1 right here, and we're going to multiply it again. But this time, we're going to multiply by the 21 that's right there, because we want to know how many is in 21. So if we have 21 cups of flour, we have 42 cups of sugar. So we're going to type in 42 right here. We're going to submit this answer, and hopefully it will go through. And there we go. All right. So what you're going to do is we're going to look at another problem just so you understand. All right. For a given recipe, 2 cups of flour are mixed with 14 cups of sugar. How many cups of sugar should be used if 20 cups of flour? Okay, so here's 2 cups of flour, here's 14 cups of sugar. Now what we want to know is we want to get it down to 1. All right, so let's see. If we want to get rid of that right there, we're going to divide by 2. So let's see what we have. 1 cup of flour equals for 7 cups of sugar. Now, we want to get to 20, right? how many cups of sugar should be used if 20 cups of flour are used. So this time we're going to multiply that, and we're going to multiply it by 20. They just give you all kinds of numbers here. And so how many cups of sugar will we need? We will need 140 cups of sugar. All right, notice that we're taking down the number that we have on this side. So if we had 2 of them, to get it down to a 1, we divided by 2, and then we multiplied by 20. All right, let's look at the next set here. Tables of equivalent ratios with plotting. This means we're going to have a graph involved. All right, it cost Victoria $41 to send 82 text messages. We want to know the equivalent ratios, and then we want to plot the points on here. All right, well, 82 and 41, we want to know how many she gets for $1. Well, so here's $41 for 82, and we want to know how many 1 is. So we can take this 82 right here. Let's clear this out. So we're going to take our 82, and we're going to divide it by 41. Right? So she can send 2 text messages for every dollar. All right, so if she can send 2 messages for every dollar, what's it going to cost her to send 20? Well, you're going to multiply right here. If we want to get 2 going to 20, what did we multiply by? You can say 20 divided by 2. Let's clear that out. So we got 20 divided by 2, and that equals 10. So we multiplied by 10 to get there. So if we multiply this by 10, we multiply this side by 10. And 1 times 10 is 10. All right, now what we're going to do is we're going to go down and we're going to put these in our chart. Here's the dollars. Here's the text messages. All right, so dollars are our Y. Text messages are our X. So we have 2, 1. So right here, we're going to go about here because it's not exactly a half of it, and then we're going to go up 1, 2 and 1 right there. Now you're going to have to guesstimate. I can't tell you an easier way to do this part. Then we've got 10 and 20. Now that one should be easy to find. So here's 10 and here's 20 right there. All right, that one should be a little bit easier. I'm sorry, that should be 2010. Let me get rid of that because our dollars are 10, our text messages. There we go. That's better. And we can put that right there. And these are really small. I get that it's really small, but you're just going to have to kind of do the very best you can to guesstimate getting it in that spot. And I've found that Delta Math is pretty forgiving about that. So now we need to go find 82 text messages. That's going to be in here, and $41. So here's 82. And here is, well, we need it to be a little bit, yeah, okay. 82, there we go, and 41. Yeah, we're going to let that be it. Now, again, Delta Math is very forgiving. Let's hope it's very forgiving of our graph right here. And there we go. So it got it for us. And it'll kind of correct your placement if you need to. All right. We're going to go back to the next section. That's with plotting. Remember that you have to find your equivalent ratios, and then you have to plot them on there. Now, comparing rates with conversions. This one's going to be a little more complicated because they're going to give you numbers in different measurements. For example, Tony runs 8 feet per second. Noah runs 419 feet per second. And Will runs 1 mile in 390 seconds. They give it in miles per seconds here. And then we have feet in minutes. So you're going to have to figure out each one of these independently, who runs the fastest. Most of them are in seconds, so we're probably going to want to change this 1 minute to 60 seconds. And most of them are feet, so you're going to want to change your mile to feet. So if you're not sure what that is, we can go right here to a new tab. How many feet are in a mile? How many feet are in a mile? That should be 5,280. All right, and you can use this little conversion chart right here if you want to. So there's 5,280 feet in 1 mile. All right, so he runs 5,280 feet in 390 seconds. So let's see how fast that is. 5,280 divided by 390 seconds. So he runs 13.5 feet per second. All right, you may have to write that down and remember that. 13.5 feet per second. I'll tell you what we'll do. We will make a sticky note so that we can see this. I'm going to make a new note. All right, so who was that? So Will runs 13.5 feet per second. Because he runs 1 mile in 390 seconds. All right, so that's how many feet per second there. All right, now let's take a look at Emily. She runs 857 feet in 1 minute. Well, how many seconds is a minute? That's 60 seconds. So let's clear that out. And she runs 857 feet in 60 seconds. So she runs 14.3 feet per second. Let's move that over. 14.3, so Emily, 14.3 feet per second. All right. Now we have 8 feet per second, and we already know that he's not the fastest. And Noah runs 419 feet in 34 seconds. So let's figure that one out. 419 feet in 34 seconds. So let's see. 12.3. So Noah runs 12.3. We'll put that on here. Noah is 12.3 feet per second. And Tony, that's a little hard, was 8 feet per second. All right. So who runs fastest? Who's the fastest runner? That would be Emily, because she runs 14.3 feet per second. And there you go. Now, they'll give you conversions on here, but I'm going to tell you that you might want to go to Google and find a little conversion calculator so that you can do that. You could even do this. You could even put your actual measurements in here and it would convert it for you. Let's see. Let's go back here. All right. We're going to do one more problem like this, just so you feel comfortable with this. Okay, so we have feet per second again, feet per second again. Then we have mile per second, per seconds again, and then feet in a minute. So this is going to work exactly like the same last problem. So let's pull our sticky note back up. Let's pull our calculator back up and clear it out. All right, 15 feet per second is Brooke. We don't really need to write her down this time. We're going to get rid of all this. So Brooke is 15 feet per second. Okay. Now, Liz runs 204 feet in 14 seconds. So let's say 204 divided by 14. She runs 14.6. Liz is 14.6 feet per second because that's 14.5 and then it's got a 7 after it. So we'll just round it up. Let's spell her name right. Yeah, let's do that. Okay. Per second. Now, Emily runs 1 mile, which we said was 5,280 right there. So let's get her back up here. Let's clear that out. Let's get our sticky note back. All right, so we have 5,280 in 406 seconds. So we're going to divide it by 406. And that equals 13. That's Emily. 13 feet per second. All right, and now we have Frank, who runs 621 feet in 1 minute. Well, we know that 1 minute is 60 seconds, so let's do that. 621 divided by 60, 10.35. So that's Frank, and he runs 10.35 feet per second. All right, we want to know which runner is the fastest. Well, who's the fastest? That's going to be Brooke because she runs 15 feet per second. So let's submit that. And there we go. All right, that was rates with conversions. Interpret features of a proportional graph. We're going to look at that section now. A certain shade, these are going to be where you're just using this graph to kind of answer questions. It says a certain shade of green paint is made by mixing blue and yellow paint. Blue and yellow make green. The relationship between the number of quarts of blue paint is the X, and the number of quarts of yellow paint is the Y. So blue is X, and yellow is Y. So right here, if we have 2 on the X, right here, 2 on the X and 10 on the Y, that means that there are 2 quarts of blue paint. So let's look, this is 2 quarts of blue paint for every 10 quarts of green paint. No, because this is yellow paint. So we're looking for blue and yellow. All right, so this is 2 quarts of blue, but it's not green. This is 10 quarts of blue, so that's too many, and that's 10 quarts of blue. But right here we have 2 quarts of blue paint for every 10 quarts of yellow paint. So you're going to have to pay attention to these as you go through them and make sure you're looking at the right information. All right, so the ordered pair 210 means that there are 2 quarts of blue paint for every 10 quarts of yellow paint. All right, let's do one more of these. Sydney practices the piano the same number of minutes each day. The relationship between the number of days is X, the total number of minutes is Y. At point 220, which statement about the graph is true? 2 and 20. It says the unit rate is 2 days per minute. Well, does she take 2 days for a minute of practice? Or for every 2 days, is it 20 minutes of practice? So let's see. If it's 2 days to take 20 minutes, how can we make that 2 a 1? Because we want to know the number of practice minutes per day. So in order to find out what that would be, we would say 2. And how do you get it to a 1? Well, 2 divided by 2 is 1. And if we divide that by 2, we divide 20 by 2. All right, so 20 divided by 2 is 10. All right, so that means that 1 day she practices 10 minutes. So the unit rate is it 10 days per minute or 10 minutes per day? Well, for every 10 minutes, that for every day she practices every day, 1 day, 10 minutes. The unit rate is 10 minutes per day because in 2 days she practiced 20 minutes. In 3 days she would practice 30 minutes because it's 10 minutes per day. Let's do one more of these. If the point 214 lies on the graph, what does the ordered pair 214 indicate? Okay. Benjamin buys mobile games via an app store on his phone. So he's buying games. The relationship between the number of games and the total cost. All right, so the number of games is X and the total cost is Y. All right, so 2 is X, 14 is Y. X is the number of games, so 2 is the number of games, and 14 is the total cost. So if this what would this indicate? 2 is the number of games, 14 is the cost. Well, here's 2 games, and the total cost is 14. And here's 2 games, and the cost 14 each. But they're not 14 each because that was his total cost. So 2 games that cost $14 is what you're going to find there. All right, now we have gone over all the different types of problems there are on assignment 6. I want you to give this a shot. You can refer back to the video if you need to. Do not forget that you need to watch these videos in here, and I want you to give assignment 6 a shot now. Let me tell you what was going on with Delta Math that was making it not accept the answers. If your answer, for example, what I was doing was I was trying to put a comma in it, like if it was over 1,000 or whatever, I was putting the place markers in there, and it didn't like it. It just wants the numbers. So if it starts to give you fits about it and it won't let you enter the answer, make sure you're not putting commas or anything extra in it. All right. I hope that helped. And don't forget that I can set up virtual tutoring with you if you need more help. But we are going to close this one down. I'm going to process this video and upload it. And then hopefully you can watch this tomorrow and get on target. Again, I really miss you guys. Bye.